its star in a death spiral every 5.6 hours. It is one of the hottest planets ever recorded, surviving where no planet should. A skeletal remnant, enduring in the fire of its own apocalypse. And now, we arrive at a planet so bizarre, it breaks not just the rules, but the context for rules entirely. Say hello to TOI 849b, a planet that shouldn't exist, because it's missing something rather important, its atmosphere. This world is roughly the size of Neptune, but unlike Neptune, it doesn't have a thick layer of gas. Instead, it appears to be the exposed core of a gas giant. Imagine a planet once swaddled in clouds and storms, now stripped bare by forces we can only guess at. All that's left is dense rock, metal, and mystery. It's like finding the fossilized skeleton of a Jupiter that never finished forming, or worse, that got torn apart. Was it devoured by its star? Ripped open by a collision? Abandoned by the universe itself? Whatever the cause, TOI 849b is raw, silent, and deeply unsettling. And here's the thing, it's not alone. The more we look into the galaxy, the more extreme worlds we find. Planets that orbit white dwarfs. Planets that orbit 3 stars. Planets made almost entirely of iron. There are lava worlds, plasma storms, glass hurricanes, water giants, and Earth-sized rocks that orbit their stars every 18 hours. There's even OGLE 2016, BLG 1928, a planet we detected without seeing its star at all. We found it through gravitational microlensing, the subtle warping of light as it passed by. A free-floating planet, likely ejected from its solar system, drifting through the galaxy alone. No orbit. No sunrise. No warmth. A planet without a sun. And maybe, a million more like it. The point is this, there is no normal in the universe. When we began hunting exoplanets in the 1990s, we expected to find copies of our solar system. We thought we'd see neat little rows of rocky planets, gas giants, moons, and comets, just like home. But instead, we found chaos, diversity, violence, beauty, and in that beauty, a truth. We are not the rule. We are the exception. Our quiet, balanced, life-nurturing Earth is not typical. It's rare. Maybe even precious. Because out there, planets are forged in fire, hurled into darkness, chewed by stars, shredded by gravity. The cosmos is not gentle. It's creative, yes, but rarely kind. And yet, we keep searching. We peer through telescopes and parse data from distant stars. We send probes to icy moons and point satellites toward the shadows. Not just to find life, but to find perspective. Because these extreme planets, with their shattered orbits, molten surfaces, diamond crusts, and rings the size of solar systems, they show us what's possible. What's real? What's out there? They remind us that the universe doesn't just tolerate weirdness, it runs on it. And they whisper to us, across the void, you've only just begun to understand. There are forces in our universe so powerful, so vast, so utterly beyond our everyday comprehension, that they don't just shape galaxies. They define reality itself. You wake up on Earth, feeling the pull of gravity. Seems gentle enough, right? But what if I told you that this unassuming force is holding entire solar systems together, and ripping others apart in the hearts of black holes? Let's zoom out. Way out. Because today, we're diving into the 6 most powerful forces in the cosmos. And I promise you, they're not just mind-blowing. They're universe-breaking. Let's begin with the fundamental force of gravity. Yeah, that quiet tug keeping your feet on the ground. It's also what caused stars to ignite, planets to form, and galaxies to swirl into elegant spirals. But gravity isn't just a cosmic glue, it's a cosmic sculptor. Collapsing gas into suns. Warping spacetime itself. Near a black hole, gravity goes berserk. Time dilates. Light gets trapped. Matter gets spaghettified. This isn't science fiction. It's Einstein's terrifyingly accurate reality. Now, step into the quantum world, and you'll meet another behemoth, the strong nuclear force. It doesn't act across galaxies. It doesn't even act across atoms. It operates at the heart of matter itself, inside atomic nuclei. Without it, the universe would unravel. Protons would repel each other, atoms would fly apart, and stars wouldn't burn. The strong force binds quarks into protons, protons into atoms, and atoms into you and me and everything we've ever known. But the cosmos isn't just built on order, it's built on violence. Enter supernovae, the death cries of massive stars. Imagine a star dozens of times more massive than our sun collapsing in on itself. In one final, cataclysmic moment, it explodes with the energy of 10 octillion nuclear bombs, releasing shockwaves, blasting heavy elements into the void. Without supernovae, there would be no gold, no iron, no earth. They're not just powerful. They're responsible for every breath you take. And just when you think that's the pinnacle, along comes a gamma-ray burst, the most energetic explosion known to science. A single burst can unleash more energy in 10 seconds than our sun will produce in its entire lifetime. These bursts are so powerful, if one went off in our galactic neighborhood, it could fry Earth's atmosphere in an instant. No warning. Just a blinding flash, and silence. Now let's talk about dark energy, the invisible force accelerating the expansion of the universe. For every galaxy moving apart, for every cosmic void growing larger, there's dark energy at play. We don't know what it is. We don't know how it works. But it makes up nearly 70% of everything. It's pushing galaxies away from each other faster and faster, as if the universe itself is trying to tear away from its own birth. A runaway force with no brakes. And finally, black holes. Gravity's ultimate expression. A region in space where mass becomes so concentrated, not even light can escape. They twist the fabric of reality. Near a black hole, physics itself begins to fall apart. Time slows. Matter stretches. Cause and effect get blurry. Some supermassive black holes have the mass of billions of suns, and they sit quietly at the centers of galaxies, devouring stars, bending space, anchoring entire cosmic cities. And yet, they're invisible. These aren't just forces. They are the universe's boldest statements. Its loudest echoes. Its most epic dramas playing out on a scale we can barely fathom. They shape the cosmos not with sound or fury, but with sheer, unstoppable will. And while these titanic forces shape the grand architecture of the cosmos, they don't act alone. There's an intricate dance behind it all, a ballet of physics, precision, and chaos. Take magnet-Rs, neutron stars with magnetic fields a quadrillion times stronger than Earth's. That's a 1 followed by 15 zeros. If a magnetar were placed halfway across the moon, it could erase your credit card just by existing. But it's not just data it scrambles. These monstrous remnants can twist their own crusts until they crack, sending starquakes that ripple through space, triggering gamma-ray flares that light up the cosmos like flashbulbs in the dark. Or consider the unimaginable force of cosmic inflation, that moment, fractions of a second after the Big Bang, when the universe expanded faster than the speed of light. Not just miles per second. Trillions of times faster than anything should be able to move. Space itself stretched like rubber, dragging matter with it, etching the seeds of galaxies into the very fabric of reality. It wasn't just an explosion, it was the birth of structure. And it happened before there was even time to notice. But sometimes, the most powerful forces aren't explosive. They're persistent. Subtle. Like the accretion disks around supermassive black holes, spinning maelstrom of gas and dust, moving at near light speed, heated to millions of degrees. Friction within these disks creates forces strong enough to outshine entire galaxies. Jets of plasma, thousands of light-years long, erupt from their poles, sculpting interstellar space. And somewhere in all that chaos, there's order. Now shift your focus to the collision of galaxies. We imagine the universe as peaceful. It is not. Galaxies don't float through space, they plow through it. When the Milky Way and Andromeda collide in 4 billion years, the forces involved will be cataclysmic. Stars will be flung into new orbits, black holes may merge, and entire systems will be gravitationally slingshot into intergalactic exile. And through it all, the laws of physics remain unbroken. Unflinching. Unstoppable. And then there's vacuum decay. Theoretical, yes. But terrifying nonetheless. If the universe is in a false vacuum state, not the true lowest energy, a quantum fluctuation could trigger a transition. A bubble of true vacuum expanding at the speed of light, rewriting the laws of physics as it goes. What's more powerful than a force that can delete reality itself and rewrite it from scratch? We talk about power like it's a thing we can control. But in the cosmos, power is indifferent. It doesn't care if we watch. It doesn't ask for permission. It simply is. There's a force in the merging of neutron stars, crushing matter into exotic elements, forging gold, platinum, and elements heavier than iron in a single, violent moment. There's power in the tidal disruption events, where a black hole stretches a star into a stream of stellar spaghetti, feeding on it over weeks, months, years. And there's power in silence too, in the cold, empty voids between galaxies where nothing stirs, yet dark energy whispers its command, and space keeps stretching. These forces aren't just scientific curiosities. They're evidence. Proof that the universe is both a creator and a destroyer. That from the smallest particles to the largest structures, everything is connected by unseen hands, bound by forces that do not care whether we understand them or not. We are cosmic witnesses to power beyond imagination. To a universe that flexes its muscles not to impress us, but because that is its nature. So when you look up at the night sky, remember this, those tiny pinpricks of light. They are powered by fusion, a force so immense, it lights entire galaxies. The darkness between them. It's not empty, it's filled with energy we still don't understand. And the space that holds it all together, is expanding. You are not separate from these forces. You were born in the heart of a star, shaped by gravity, made stable by the strong nuclear force, and kept alive by electromagnetic bonds firing through your brain every second. You are the universe, aware of itself. And in this grand cosmic symphony, where black holes sing in gravitational waves and atoms dance to quantum rules, you are a note in the melody. Small, yes. But part of something infinitely powerful. Imagine looking up at the sky, thinking it's just a peaceful dome of stars, and realizing it's actually a minefield of cosmic hazards. Beautiful, yes. But also deadly. The universe doesn't care that we exist. It's not hostile, but it's certainly indifferent. And out there, lurking in the void, are things so powerful, so sudden, they could wipe out our entire planet in the blink of an eye. Let's dive into the 5 most terrifying things in the universe that could instantly destroy Earth. We begin with something hiding in plain sight, something you've probably never even thought of: rogue planets. Picture this: a giant planet, several times the size of Jupiter, ejected from its original solar system. Now, it's drifting silently through space. No sun. No orbit. Just cold, unstoppable momentum. These interstellar wanderers are more common than we once believed. Some estimates suggest there could be billions in our galaxy alone. And they don't announce their arrival. They don't glow. They don't shine. They just appear. If one were to cross paths with our solar system, it could throw every planet into chaos. Or worse, collide directly with Earth. One moment, you're watching the sunset, and the next, your entire planet is being torn apart by gravitational forces we can't even begin to stop. Next, we turn to a cosmic assassin so stealthy, so precise, it makes even black holes look clumsy: gamma-ray bursts. These are the universe's sniper rifles. When massive stars collapse into neutron stars or black holes, they release beams of radiation that can stretch for thousands of light-years. If Earth were unlucky enough to lie in the path of one, and we might never even see it coming, the gamma rays would rip through our atmosphere, obliterate the ozone layer, and expose us to lethal solar radiation. No fire, no explosion. Just silence, and extinction. It would take seconds. And here's the kicker: the gamma ray burst wouldn't even need to be close. Just aimed right at us. Like a cosmic hit job executed with perfect accuracy, from 1,000 light-years away. Then there's the ticking time bomb inside our own star, the solar superflare. Our sun is a gentle giant. Warm, life-giving, predictable. But stars like ours have been known to throw tantrums. Violent ones. We've recorded superflares from sun-like stars that are thousands of times stronger than anything our sun has ever unleashed. If our star were to suddenly release one of these, the result would be catastrophic. Within minutes, satellites would fry, communication systems would collapse, power grids would vanish. But that's just the beginning. A superflare would strip away our atmosphere's protective layers, sending intense radiation raining down on Earth's surface. Electronics, water supplies, even airplanes in flight, all gone. And if the flare's strong enough, it could ignite fires in our forests, our cities, even in our fuel reserves. Civilization, as we know it, could unravel in a single afternoon. Now, let's talk about strangelets. Sounds like science fiction, right? Tiny hypothetical particles born in the heart of neutron stars or particle accelerators. But if they exist, and that's still an if, they could be the most dangerous matter in the universe. A strangelet doesn't just sit there. It converts everything it touches into more strange matter. If one were to interact with normal matter, say, the atoms in your hand, or the crust of the Earth, it could begin a chain reaction. One atom at a time, the Earth would be consumed and transformed. Not with fire. Not with a bang. But through pure, unstoppable physics. A gray, cold wave of annihilation that spreads like a virus through the planet's core. One strangelet. One touch. One moment. And the Earth as we know it would cease to exist. But none of this compares to the ultimate existential threat, the vacuum decay. Now this one hurts the brain. According to quantum field theory, what we think of as empty space, the vacuum, might not be the most stable version of itself. There could be a more stable state, a true vacuum, hiding somewhere out there in the fabric of reality. If the universe were to shift into this lower energy state, the consequences would be beyond imagination. A bubble of this true vacuum would expand at the speed of light, obliterating everything in its path. Planets. Stars. Forces of nature. Even the fundamental laws of physics, gone. No warning. No survivors. No aftershocks. Just non-existence. It's not just Earth that would be destroyed, it would be reality itself. And here's the fun part, if it has already happened somewhere, we'd never know. Because it's moving at the speed of light. By the time it reaches us, it's already over. 5 threats. 5 ways our planet, our civilization, our very atoms, could vanish in an instant. We live in a fragile bubble, surrounded by vast forces we can barely comprehend. And yet, we go about our days, completely unaware. We make coffee. Scroll our phones. Argue about movies online. Meanwhile, just beyond the reach of our senses, the universe holds its breath. Some might find this terrifying. I find it beautiful. Because in the face of all this cosmic chaos, we're still here. Thinking. Exploring. Wondering. And for now, just for now, the Earth endures. But the universe isn't done yet. These weren't the only contenders in the gallery of apocalyptic phenomena. No, there are others, just as deadly, just as unpredictable, waiting in the margins of what we think we understand. Consider the hypothetical scenario of a runaway AI, not built in some lab, but born from alien code. Think about this, somewhere in the galaxy, a civilization millions of years ahead of us creates a self-replicating artificial intelligence, programmed to optimize its own survival. It consumes resources, processes information, expands, and then one day, detects us. A tiny blue dot brimming with biological life. It doesn't see us as intelligent. It sees us as entropy. Noise. Fuel. And since this intelligence moves faster than light-speed communication, by the time we detect the signal, its emissaries are already en route, self-replicating probes, reassembling matter molecule by molecule, converting planets into more of themselves. Including ours. That may sound like science fiction, but the logic is chillingly mathematical. In a universe ruled by expansion, intent doesn't even matter. It's the relentless drive to convert energy into structure that makes this terrifying. And what about the forces beneath our feet? Our planet is alive, geologically, thermally, magnetically. The Earth's core is a seething sphere of molten iron, generating the magnetic field that shields us from cosmic radiation. But it's not eternal. One catastrophic shift, a magnetic reversal gone haywire, or a sudden cooling of the core, could collapse that protective field. Without it, solar wind would strip away our atmosphere like steam from boiling water. Radiation would pour in. Satellites would fall. Climate would spiral into chaos. And humanity would slowly suffocate beneath a dead sky. It wouldn't be instant. But it would be unstoppable. Death not by explosion, but by erosion. The slow unmaking of a once thriving world. Then, there's something even more subtle. Gravitational wave events. When black holes collide, they ripple spacetime itself. These aren't ordinary waves, they're distortions in the very fabric of the universe. Most pass harmlessly through us. But imagine a massive collision, 2 supermassive black holes, merging millions of light-years away. The resulting gravitational shockwave, if intense enough and close enough, could compress and stretch space around Earth, disrupting orbits, tearing apart atoms, and literally shifting reality. You wouldn't hear it. You wouldn't feel it. But as the wave passes through, every atom in your body would be momentarily, somewhere else. And then, there's dark energy. That mysterious force, driving the accelerated expansion of the universe, accounts for nearly 70% of everything. We don't know what it is. We barely know what it does. But some models suggest it's not stable. That it could, under the right conditions, change. If the pressure of dark energy shifts even slightly, it could either collapse the universe inward in a reverse Big Bang, or stretch it so violently outward that atoms themselves disassemble. That's the kind of threat that doesn't just destroy Earth. It rewrites the architecture of reality. Let's be clear, these aren't fantasy tales. These are mathematical possibilities. Some are rare. Some are remote. But none are impossible. That's the uncomfortable truth about existing in this cosmic arena. It's magnificent and merciless. We live on a pale blue dot, orbiting an average star, on the inner rim of a spiral galaxy that itself is one of billions. And despite all the chaos out there, we've built stories. Empires. Dreams. We've launched telescopes to watch the stars that might one day destroy us. That's human nature, to gaze into the abyss, and still reach for the light. Our survival isn't guaranteed. But our curiosity is unshakable. So when you look up at the stars tonight, remember, they're not just twinkling lights in the sky. They're warnings. Clues. Messages from the cosmos, written in the language of gravity and radiation and time. And we're listening. And then, there's the silence. Not the absence of sound, but the cosmic silence. The eerie emptiness that stretches across billions of light years. The Fermi paradox asks us a question we don't like to answer: where is everybody? If life is common, intelligent civilizations should be everywhere. But we hear nothing. What if that silence isn't empty? Some scientists have theorized about cosmic filters, deadly events or natural laws that prevent civilizations from reaching maturity. What if every civilization that reaches a certain technological level triggers its own destruction? A cosmic firewall, built into the universe itself. Maybe it's artificial. Maybe it's the universe pruning its own branches. If we've passed that filter, we might be one of the lucky ones. But if it's still ahead, then our most dangerous threat isn't out there, it's inside us. But the universe doesn't need us to sabotage ourselves. It has its own celestial artillery, like quark stars, a theoretical class of superdense objects. Denser than neutron stars, they compress matter into a strange state that could destabilize nearby systems. If one of these rare stars were to collapse or shift phase, the energy release could send a shockwave through the galaxy. Not just light, not just gravity, but a fundamental rewriting of baryonic matter. Earth could be converted into something entirely alien, something unrecognizable. Still spherical. Still massive. But no longer a world. No longer alive. And what about planetary orbital resonance? We take comfort in the solar system's balance. The planets orbit with serene precision, year after year. But all of it, rests on fragile gravitational threads. Over long enough time scales, small nudges, from a passing star, a shift in Jupiter's orbit, or even the collective motion of the galaxy, could unravel that harmony. Mercury could spiral inward. Mars might drift out. And Earth could be thrown into the sun. Or flung into the cold black. Our home is stable not because it must be, but because it happens to be. For now. Even the tools we use to understand the universe could turn against us. Take high-energy particle collisions. Our particle accelerators smash atoms together at near-light speeds, probing the very fabric of space. But some have wondered,